With great data comes even greater access latency. This is the Trino Community Broadcast. I'm your co-host, Brian Olson.
And co-hosting again, Manfred Moser today.
And today we have two wonderful guests that are joining us from the Pinot community. Welcome, Zhang, and welcome, Elon.
Hi, this is Charles. So I'm a Pinot committer and glad to be joined here.
And
Hi,
Go ahead.
My name's Elon, and I'm a software engineer. I used to work on the Presto team at Facebook and left to join a stealth mode startup and work with both Pinot and Trino.
Awesome. Thanks for coming, you guys. And just wanted to quickly go over what we're going to be talking about today. So obviously, we're going to be talking about Pinot, and we'll get into what exactly that is for those that don't know. A lot of folks on here are coming from like Trino, and so maybe aren't quite familiar. Maybe you've seen it in passing because it's just one of the connectors that we've added in the last year? It's almost been a year now, right? Since we added the Pinot connector. Is that right?
I think so.
Yeah. So anyways, so we'll be going into that and covering a couple of things. First, I'd like to have a quick word from the sponsor, Starburst, and we'll be back right after that. And quick note on this. This is a new thing I'm trying. We have a kind of a more professional video, and I'm going to try to get some feedback from some of the audience to see if they like this or if they want me to make a video that we had before where I just sat there and talked about some of the things that Starburst offers. So
are you saying you're not a professional, Brian?
I'm not at all. In fact, I think that's kind of why they hired me. I don't know. So let's see if we can bring in the professional aspect and see if folks like this more than me just sitting there talking to a mic. We'll see.
The explosion of data sources has forced organizations to modernize their systems and architecture and come to terms with one size does not fit all for data management. Today, your teams are constantly moving and copying data, which requires time, management, and in some cases, double paying for compute resources. Instead, what if you could access all your data anywhere using the BI tools and SQL skills your users already have? And what if this also included enterprise security and fast performance? With Starburst Enterprise, you can provide your data consumers with a single point of secure access to all of your data, no matter where it lives. With features like strict fine-grained access control, end-to-end data encryption, and data masking, Starburst meets the security standards of the largest companies. Starburst Enterprise can easily be deployed anywhere and managed with insights, where data teams holistically view their cluster's operation and query execution so they can reach meaningful business decisions faster. All this with the support of the largest team of Trino experts in the world, delivering fully tested, stable releases and available to support you 24/7. To unlock the value in all of your data, you need a solution that easily fits with what you have today and can adapt to your architecture tomorrow. Starburst Enterprise gives you the fastest path from big data to better decisions, because your team can't afford to wait. Trino was created to empower analytics anywhere, and Starburst Enterprise was created to give you the enterprise-grade performance, connectivity, security, management, and support your company needs. Organizations like Zalando, Comcast, and FINRA rely on Starburst to move their businesses forward. Contact us to get started.
All right. So I don't know. Let me know what you all think of that. If you're more for the kind of casual me just spouting off what the differences are versus something like that. Anyways, because that's probably what you'll be hearing in the beginning of these shows for I don't know how long we'll do this. There's probably plenty of shows and plenty of ground to cover with Trino, so it's going to be a long time. So let me know what you all think. If it's going to be what's the more interesting thing to hear. With that, let's go ahead and move on to the release. Manfred, do you want to spout us up? Let me pull us into the code scene here. And
yeah, so the first problem with the release starts with what release are we even going to talk about? Because we talked about the 3.5.3 release as an emergency release kind of twice. And it turns out that now we are just about to pump out the 3.5.4 release in the next days or so. But today we're going to focus around 3.5.3, and then next time we'll talk about 3.5.4 when it's actually released, not like last time.
Yeah.
So again, recapturing a little bit what happened. there was a little correctness bug that we thought we should cut and release for ultimately really fast. Didn't turn out that fast. And then the release 353 ended up being pretty big in the end as well, right? Like probably Brian celebrated the most last time having a new connector, obviously, right? Like, tick, another one.
Yep.
So we got that ClickHouse connector out. But then there's a bunch of other things like the BigQuery connector from Google got create and drop table added, which is so that adds on top of the OLAP functionality to actually do a little bit of like data migration and that kind of stuff. We got unnest support, very cool support. We got is the Glue Meta Store, where if you use the Hive connector and you use the Glue Meta Store, the Glue catalog in Amazon, it now can use the native statistics. So up to now, the statistics were automatically inserted by Trino, and then those statistics were used, and the native statistics maintained and updated by Glue were not used. But now it's possible to migrate so that you can leave Glue to deal with it, and that of course lightens the load on Trino itself. And it's a seamless migration as well, because it basically can keep using the old ones but also adapt new ones when they exist. So you won't have any problems migrating to the new one. And then once that's done, then you don't have to worry about it anymore. So it's really nice. Cool thing that happened also was interesting discussion on the PR, I found anyway. Apache Phoenix 5.1 is supported. The way we had to do that is basically the Phoenix connector is kind of like a sort of like semi-forked in the code base to be two connectors. So there's two different connector names, you know, in the catalog when you configure connector.name equals whatever. There's now one for Phoenix 5. We had to do some class loading magic because there were some incompatibilities in the API and stuff like that we had to deal with. Pretty interesting approach the developers took there. It was fun to see the discussions around that. And that's also in. Couple of other things that those were sort of the highlights from Martin in the official release notes. As you know, the official release notes is always pretty long because a lot of stuff goes on. I read through this a few, and I wanted to mention a few other things as well. So we added some geometry functions again. There were a whole bunch, if you look in the general section of the release notes, a whole bunch of correctness and performance improvements, like it goes like fix this and fix that. Like there's a whole bunch of them. Literally just read it through because it goes pretty into details. One thing that was requested quite a bit from users of the RPM-based installs that was also a long coming, hairy kind of thing to figure out. As you know, Trino has secret support, so you can have passwords and stuff encoded so that it's get picked up from the environment variables that you set externally via your provisioning tool or whatever, so that you don't have to have any secrets like passwords or so saved on the catalog files on the disk. Now that, however, didn't really work with the RPM for some reason. And we finally got that implemented. There's this env.sh script that can now at startup load those correctly. And so you can now use secrets on RPM-based installs. So if you're using an RPM-based install, definitely check that out. The Hive connector, apart from the Glue statistics, got a few other things. I specifically wanted to mention that the performance improvements on the bucketed table inserts were pretty significant. So if you are using bucketed tables, that's pretty cool.
That's good.
It's really good. So the Hive connector always gets a lot of enhancements. I'm not sure how this is happening, but obviously it has a lot of footprint of all the things it supports. One connector that's gotten dramatically changed or improved in the recent little while is the Kafka connector. It now has a schema registry support, and that got improved quite a lot again with this release. So that's really come along really nicely.
Is that the like Hortonworks registry, or is there like a generic API?
No, it's Confluent.
Oh, Confluent has their own kind of schema registry. I at one point I'd used the Hortonworks like schema registry. They had their own thing. I don't know if it's like kind of based off the same type of API.
I think they're kind of related, but the main standard one is Confluent, and cool. It's pretty much like the accepted way to do this now in the Kafka world.
Great.
And that's really good. If you're using that and you need even more improvements, definitely check out the Starburst version of it. It has like HTTPS support for the schema registry and a bunch of other additional things as well.
Cool.
The JDBC connectors got an experimental join push down, which is pretty cool to have. So there's a bunch of those JDBC connectors have them. You see in the list which ones. But like definitely the common one like Postgres, MySQL, Oracle, and others. They have that as an experimental feature that you have to enable with a toggle. If you want to play around with that, that would be awesome. And tell us how it's working out for you. That would definitely help. There's a bunch of other fixes on JBC connectors as well. And then the big one that Brian just scrolling to, SPI. There's a bunch of changes. Obviously, if you're not working against the SPI because you're not implementing a connector or so, you don't have to worry about it. But otherwise, if you have some sort of custom plugin for an authorization or you're maintainer of a plugin, Zhang, that's the one. You want to look at that one.
Yeah, so I mean that's always the interesting ones to see come through on these, and when this was supposed to be such a small release, you're like, okay, that's definitely, you know, you'll see a couple of these connector ones, you know, pile in, but to see this many SPI changes, you're just like, whoa. So it just usually they're small changes individually, but they, you know, it's the aggregate of them are a little bit bigger than what we usually see on a single release, but it's great. It's a lot of really long requested stuff that's been kind of finally coming through and getting completed. So, yeah.
By the way, Shang, my impression is that typically when the SPI changes, it's not too bad, right? Like you literally just update your code base. Like the IDE will throw the error, like show you the errors, and you just like change it over to the new signatures. It's pretty much a pretty simple change in most of the time, right?
Technically, yes. It's mostly about ID show me like all the exceptions to my face, and I'll probably go to take a look at all the interfaces changed and say like if there's any guidelines of like this thing moved to that or something doesn't work. And typically the best practice is that we put the those SPIs into like deprecated things, those APIs. And then people will have some like factories to figure out how to migrate. And also the best of that is that we can provide some sample migration change PR for the connectors. So you can point in like all the connector developers to that PR by saying like, here is how we do migration for these example things. And then people can just follow.
I think a lot of things when it's like a breaking change, they automatically implement it in all the connectors as well, right? So it's easy.
Yeah,
that's cool.
Very cool. Speaking
and then,
of,
yeah, as I mentioned, 354 is around the corner. There's a PR for a critical fix that we want to get going for some org asset transaction stuff. So hopefully this week, but I'll tell you more next time.
For sure. All right. So speaking of, let's move on into the concept of the week. Speaking of the Pinot and Trino connector, I like how they rhyme too. By the way, we see Commander Bun Bun sitting here sipping on a little bit of Pinot this morning. So a little bit early, but I mean, I told him just lay it easy on the sauce this early. Real quick question while we're on this whole subject of wine, Zhang, who came up with Pinot and where did that name come from? I've always been curious to know that.
Okay, it's like a very long history at Uber.
Okay.
No, not Uber, that LinkedIn, sorry. So basically we started this project like from 2013 or 2014. Mm-hmm. And at that time, we basically, because the entire team are like drinking this kind of wine. Mm-hmm. And we also figuring out that Pinot are coming from like grapes, right? So for all those grapes, we basically treat them as like more like data cubes, and we are trying to extract all of them, and we want to like make like good wines, trying to extract all the best of that data into our like users. That's how we are coming up with this name at the very beginning. Cool. However, the funny thing is that eventually this team become like all whiskey lovers. That was the funniest thing.
So the when you had the meetups and things like that, or everybody getting together, then nobody was drinking Pinot wine anymore. It was all tea.
Uh, we're not promoting like alcohol things in our working environment though. But
Yeah.
definitely it's like people kind of love this wine and also love like how this wine has been made. This kind of like this fermentation and everything
Yep.
behind it, and also like this kind of spirits.
Yeah, back in so quick tangential thing, totally not related to the show. When I was working or as a research assistant at Purdue, I was in a lab where basically one of the projects on there was we would take in these the sensory data that we kind of buried these sensors into the mud and would be underneath a vineyard, and so you would just be taking moisture and temperature samples every few seconds and feeding that data into basically some visualizations to help wine growers to understand, based on the soil aggregation in this area, based on the water and the temperatures at this particular low level, what is the recommendations of where we should basically be watering, because California is super restricted on how they can use water, as well as you don't want to overwater your wine or else your grapes are going to be too moisturous, and it's not you basically want to kind of have it to where it's kind of struggling a little bit. The grape is struggling to live, but you don't want it to die. That's what makes a perfect wine. So there's a lot of calculation that goes into how to make a really good dry wine, and yeah, so that's totally aside actual talking about wine.
But getting back to the topic, I really like the analogy you brought up, Xing, that curating fruit or from whiskey making, also the distilling process is very similar to dealing with a whole mess of data and getting good insights out of it, right? It's really an art in both cases, and I think that's a really cool analogy, I think. So I like that.
We were going to go with Commander Bun Bun harvesting carrots. Data was going to be the carrot, or carrot was going to be the data, and then Commander Bun Bun was going to be our little carrot harvester. But very cool. I like that analogy as well. So part of our concept, I figured there's a lot of this is kind of a generalized topic. So talking about multidimensional OLAP is going to be kind of the part that I'm going to discuss, and then we're going to get more specifically into Pinot. A couple of times in things that I've read in relation to Pinot, we talk about MOLAP and talk about these kind of data cubes. And this is not necessarily, I'm not going to say, I think maybe this might be something that Pinot uses, but I don't know if this is the exact data structure. I think they use was it a star kind of structure?
Star tree. Yeah, so
star
this
tree.
Typically is in modern generation, how people are doing data analytics.
Okay.
So this is all the topics that they cannot bypass. It's basically how you do analytics on top of your raw data, and how you accelerating, how you accelerate your data, and data analytics, and how you basically accelerating when you access the data, and this is how you process it.
Yeah.
So it's typically from the data transformation, we use this cubing things to represent this data.
Yeah.
In a dimensional way.
So data cubes are more, I guess, on a conceptual level, not necessarily the exact data structure that you're going to be actually representing the data in internally, correct?
Yeah.
Because I've heard in one of the blogs that you wrote, you talked about cubing, and so that's why I kind of wanted to give a little bit of this background as to conceptualize what's being done here. And so what data cubing essentially is in MOLAP is you are trying to kind of take these dimensions within your data. So these would be just particular columns that you're typically grouping the data by. So you usually have something in this particular example, we have a data cube that has 3 dimensions. It's easy to visualize anyways. And you'd have something like a part number or a store location or a customer. And a lot of times you're trying to kind of ask questions of like, what are the counts by part number, by customer, by store location. So you would, usually have like a select statement saying like select part, store, customer, and then give me the counts. And then you're going to say, give me this from this cube table. So if you have a table that does not have this kind of cube or multidimensional cube where this data has been grouped already, you have to actually go out to your table and scan every single row and basically perform that aggregation ad hoc, right? And this is in part, unless we have some pre-saved kind of cache data, this is in part kind of what Trino has to do because we are handling this kind of ad hoc analysis. But then what data stores like Pinot try to do is they try to kind of make a data store, not necessarily represented this exact way, but they try to kind of have this data pre-aggregated. And so you can visualize it or picture it conceptually as being this kind of data cube where all of these answers have been pre-computed, and basically you can then take this cube and perform operations on this subset of this like kind of aggregated data. And this will answer a lot of the queries that you're trying to basically go out and ask the questions. So another example would be if you're interested specifically in the customer Bob, you could look at this cube and start splitting it into these little slices. And what you would do is you would say, ask a question like select part and store and give me the counts of part and store where the customer is Bob. And this is actually going to, based on a customer where they have, again, I don't know exactly how this would relate to a real world scenario, but based on where the customer is equal to Bob, you're going to get the parts and the stores where Bob is the customer, and then basically get all of those counts. And so it's going to narrow it from a 3-dimensional cube to basically like a 2-dimensional cube with all these different counts that you're interested in. Now, a lot of times, maybe you're going to be more interested in the aggregate over every single customer. So you can do this operation called a roll-up. And so these would be basically taking all of the dimensions of one particular dimensions. So let's say the customer dimension, and you're going to actually flatten that into a single structure and perform some sort of count over that. So you basically want to sum, and this is I actually just realized I kind of screwed up the sequel here, but the concept is that you would aggregate these counts that are coming from let's say part and store location over all the customers, and you want to either sum those counts or do any various, maybe average those counts and try to get an understanding of what's happening across all customers. And so these hypercubes or these multidimensional cubes that are just basically taking aggregates of your data, these kind of give you some ability to run all of this aggregation and these types of queries without having to really scan every single row again, and you basically can pre-aggregate this data. So with that said, this is kind of where we're getting to with Pinot. Pinot is solving for this problem of basically pre-aggregating data so that you don't have to scan over multiple rows, and also so you have a more dependable turnaround in your queries. So if you're not having to depend on network latencies and scanning every single row in, you now have a much more dependable and understandable way to reason about how fast something should be returning versus all sorts of variables whenever you're transmitting a whole bunch of data. So with that, I'm going to kind of hand this over to Zheng and kind of say like, Zheng, tell us about Apache Pinot from your perspective and kind of what problems it's solving and this type of thing. So, and I can pull up the any of the references whenever you want me to.
Oh, sure. Thanks. Yeah, thanks for that very detailed introductions. And yeah, this is kind of the problem most of the OLAP store are trying to solve. So for particularly for Apache Pinot, this is like data store we are building from LinkedIn, especially for the low latency analytics. So right now, when I say low latency, it includes both low ingestion latency as well as low query latency. So this means that Pinot can extracting data directly from Kafka, so that once your data is in, once you dump your data into Kafka, you can let the data be consumed by Pinot and query it immediately. It's like seconds delay. You just see your data, and apart from like Kafka, Pinot can also import data from deep store like HDFS or like S3. And then Pinot has many index technologies. One is like invert index. It can help user to clone the data. For example, in your previous example, you have like this customer equals Bob, right? If you have invert index, you already can bypass all the customers. Their name are not Bob, right? So this is the kind of the indexing technology to accelerate the query scanning. Apart from that, Pinot also has this kind of thing called the star tree. So this star tree technology, you can probably plot that graph. So of this latency versus
oh yeah, let me go ahead and show that.
Yeah.
So
if
for the podcast listeners, just look at your show notes. There's a chart called latency versus flexibility. Go ahead.
Right. Yeah. I'll try to explain it like more verbally. So
sure.
Yeah. So basically, when we are looking at like data analytics, right? So we have like everything in raw, and basically we probably don't know what to query or what to analyze. At that point, we typically go to like a data lake and go to Trino to say, okay, I want to take a look at what's the schema of these two tables, and I probably want to extract some columns from like my dimensional table, like my user dimensions. And then I want to, let's say, aggregate on like my order table, right? Let's say I'm an e-commerce company. I want to analyze my user behavior, my customer behavior based on all the order data, right? And I have all the order table with like all the customer ID. And I want to probably do some drawing with the customer dimensions, and I can analyze things like I want to do grouping based on like the locations. So I will see which groceries are like very popular, let's say in the area, right? And once we're figuring out that this is something like I'm really interested, and it will be this thing will be super useful for our data scientists or like data analysts. Or for the CEO to view or CFO to view this report. We're actually trying to make this thing to be super fast, so that people can do it just by one click. Right? And that's at this time, we will basically need to do things like first we need to do a pre-drawing of this two table, and then we generate like one big table, right? So in terms of that, you basically have like all your order data. And it's also being decorated with all the member dimensions. So you will have like a very fat table, and that table will have like all your order information as well as all the customer information. And now you can actually do a big group by on top of that, and it will bypass the joining. So it will still use some computational cost. However, you will have like storage. Actual storage to store this data, and later on you'll find out, okay, I want this thing to be even more faster, and then you're actually going to the pre-aggregation, which means that I actually want to do like sum on this let's say all the sales amount. So you will see this number to be popping up for like United States. So when you look at my United States sales, you don't need to do all the sums across all the records. You just look at one number, you will get US sales amount. And this thing later on will go to this cubing things, because I want to see all the dimensional data. Basically I want to see my sales number by everything, right? So this thing will comes up to be like I can make everything to be just a lookup. All my query is just one lookup. Let's say I can group by who is the user Bob, and where this Bob is. Bob can be like in Bay Area, or Bob can buy something probably in Los Angeles. And you will see all those data, and you can always look them up in O1 time. However, this causing a problem. We call it like a dimensional explode, which means that in order to generate this kind of data, you need to generate extra records, which proportional to all your dimensional multiplications. So this means that later on, let's say if you add one more dimension into your customer field, into your customer table, and after you join, so you're going to have X times of your table size. So this thing is kind of not really scale. So we basically invented this like the star tree kind of technology, which can help users to do partial kind of aggregations, so that it allows the user to skip those very few number of records aggregations, which means that user can get whatever this pre-aggregated values by not scanning more than X number of records. This is like a pretty advanced thing, because typically when we are saying we want to get the sales amount, let's say for United States, typically you have like so many orders, like millions of orders. And in order to get that, you just need to read one record, right? However, let's say if I want to get how many orders for a particular zip code, it may be just 10. In terms of that, you may not want to create extra one record for this 10 record scan. You can probably afford the cost by saying, okay, I can scan 10 records and get my results. And you can set this threshold. Basically, when you generate this index, you can say, okay, I can afford to scan 1,000 records to get my answer. So Pinot will not pre-aggregate any results that requires scanning fewer than 1,000 records. So that can drastically reduce the storage cost from your data set perspective. And this is also how we are basically make Pinot super fast, and this can like serve most of the users' requirements.
Quick question, Zhang, is like so it sounds like does this mean that Pinot has this ability to kind of, based on the shape of the data, you could say, or based on like how highly the dimensionality, that's the word I'm looking for. Based on the dimensionality, Pinot tries to make a smart decision. So my thought here is I'm brand new coming into Pinot, and I don't know yet how to get into the nitty gritty. Pinot is making some smart decisions for me based on the data that I'm sending to it, right? So a high dimensionality set of data, maybe you're going to be a little more kind of conservative on how much you're trying to apply this kind of pre-aggregation or cubing to any of the you basically don't make an aggregation over all the data, right? You're trying to look at, let's say, some of the values, and if these values are going to be, like over 1,000 or some X number of values, you're gonna basically say, okay, this is gonna make a huge amount of cache to this particular dimension. So let's say it's like one of those continuous type of columns where it's like real numbers or something like that. There's going to be, you can't really bucket that so easily unless, you have the user maybe make some smart decisions of saying, between, these particular ranges, bucket it into this. But like you would if you treat a real value as like or continuous column as like something that's maybe more discrete, then you're going to basically have this huge explosion, right? So you wouldn't obviously be doing that. But then, for something that has like maybe, let's say a column that has, a whole bunch of different like human inserted fields or something like that, that's a little messy. you're not going to try to blow up that particular dimension, right? You're not going to try to basically make that into an aggregate field because you're going to say there's too many values here. Is that kind of, does Pinot have those smarts to kind of?
Yes.
Okay.
Basically, this is like back to our like computer science 101 when we
Yeah.
are seeing algorithm and why we design algorithm. We always say this is like space and time complexity, right?
Yeah.
So we basically we'll basically do trade-offs between time and the space.
Yeah.
Which means that we will use extra storage to achieve fast queries, right?
Yeah.
So think of like when you are querying your entire raw table, you are going to scan billions of records to answer one question.
Yeah.
We call it high cost query, as we need to scan billions of records, right? So yeah, this is on the very left side on that graph. So basically, it is graph a little bit. We were still on that.
Sorry.
Latency with flexibility. So basically, for like raw table scan, it's basically on the left side. We have high latency, and but we also have like a high flexibility. And meanwhile, for single query, the cost is high because we need to pay like the network, disk scan, everything there, right? So
Yeah.
we call it a high cost query. And meanwhile, on the right side, if we pre-cube everything, so the lookup is like 01. So we call it low cost latency, low cost query. However, user need to pay the cost upfront, which is your storage cost. You need to store everything, right? So Pinot is kind of providing a trade-off solution, which you can actually finding any point in this kind of curve, from like highest cost to lowest cost. So it's basically you can find the trade-off between your time and space. So this is like logically or conceptually, we are helping the user based on their hardware resources, or like what's how fast they want this query to be, right? Because with Pinot, you can achieve deterministic query latency based on your SLA, based on your service level agreement.
Yep.
You can choose like what's my desired latency, and I can use the minimal storage to help user to achieve that.
Gotcha.
It's not necessarily to be like pre-cube everything.
Yeah.
Yeah.
Yeah, I think the part I'm thinking of too is like people that are making their journey into Pinot. If they don't know anything about this, I guess you kind of try to take a somewhat conservative approach, but not like you still want to make things faster, right? So you're kind of somewhere in the middle, and then ideally, once they become a more advanced, well-versed user, they'll be able to kind of understand, okay, I'm going to make this particular trade-off here and maybe make this column or this part of my query a little closer to the low latency but low flexibility side, and then I'm going to kind of, basically make more adjustments based on my access patterns and tune that a little bit more. So you give them the option to know nothing and still have a pretty good out of the box experience, I'm guessing.
Right. Basically, as long as the user understand what kind of aggregation they want to do, then they can just create that index.
Great.
Go ahead.
Yeah, so on the aggregations, I'm guessing the typical dimensions people are aggregating on are like time dimension to have like quarterly, monthly, yearly, that kind of stuff. And then probably, like you mentioned earlier, also aggregation on a geographical level, where it's like per country, per state, per whatever, municipality, whatever. And then a lot of things are also on the financials, right? Like where you're aggregating on price. So those kind of like the main things, like dimension wise, where you're aggregating on, or can you think of any others? Like from a practical perspective, what data people are looking at?
From practical perspective, it's like many things, right? So apart from like, so this is like the very typical like sales data or like the factor table. So for example, you may also do aggregate based on user dimensions. Let's say you want to show your order details to your, let's say if you are like, I can take an example of Uber Eats, for example. Uber Eats provide like analytics to their restaurant owners. So for each restaurant owner, you will be able to see like what's your sales amount, what kind of all those things, right? In this case, we're actually do buy on like the restaurant ID, and we provide like the detailed restaurant level aggregations for all the restaurant owners. In this case, it's like member level aggregations. Usually for this kind of site-facing use cases, we will it's like require very deterministic correlatency, super strict P99 of correlatency for this kind of site-facing use cases, because it's providing analytics to your end users. For example, for some bank, they may want to tell you like how much you are spending at different categories. If it's like spinning there for 1 minute to generate the report, the user may already close their website. So this is like latency-wise is very critical for those site-facing use cases. Pinot is extremely advanced in this area. Basically, for example, at LinkedIn and Uber, it's been using Pinot for these site-facing use cases for like more than 5 years, and it can surface in like thousands of QPS with like less than 100 millisecond P99 latency, and these kind of things are like very how to say, this basically makes this make your data product to be able to surfacing all your whole user base instead of just the internal analytics for your internal data analyst or data scientist. Yeah.
So
yeah, that's a whole different scale then, obviously. That's cool.
So understanding kind of where this moves into like where things are very useful. You had a super useful part of we had a conversation before the show, which was driving like for some people they may be like, okay, well, a lot of my overarching queries that I'm running against my systems are typically ad hoc, right? So, but you actually have a very compelling kind of discussion that talks about bringing value to that data that's maybe not ad hoc or in the more recent times. So, could you talk a little bit about kind of how data kind of loses its value over time, and how doing measures like this kind of brings that data back into the picture?
Yeah. So for this topic, I think the most basic question we want to ask is like, why real time, right? Because when we're talking about a real time analytics, it's like low ingestion latency. So why I need a low ingestion latency? Because if we look at the data, so data has its own value. So when a single data come in, so if you get this data as fresh as possible, this data will give the user most of its value. For example, if there's like one transaction is happening, so for financial institute, they were figuring out, okay, this is a fraud transaction. So I need to lock your credit card. I need to file something. I probably need to call police. Probably not. In this case, this data value will lose if you get this data too late. Right? So if you get this fraud transaction in 1 day, it's probably too late. So basically, for single event of this value, it will decrease, and it's like decreased a lot during one time pass. So this is the one we are calling about the value decreasing for single events. However, when you aggregate everything together, the value of the data will go up. Take one example of like e-commerce, of, for example, your order data, right? So when you put an order immediately, the e-commerce shop may give you some recommendation immediately by saying, oh, you bought this, take a look at this. So this is your single event value, right? So when you bought something, they give you the recommendation. and it may attract you, and then you probably you can buy something else. So this is the value of the real-time data. And once this data to be like ingested into your data lake, and you have so many like billions of these search events, you will be able to do analyze, right? So for example, after one day, you will say, okay, how my business is going for yesterday? You can aggregate on your sales amount by saying, okay, how is the different areas doing? All those aggregate value will provide you more insights on like how your business is doing, and this is like falling into the typical business analytics area. And moreover that, for let's say for 1 year, if you are collecting like as long history as you possible, you are basically getting the time series of like how for a particular metrics in a very long time span, how it goes. It can help you to analyze like user behavior, how their purchase behavior. All those things are possible when you have many data, which means that for aggregated events, the value will go up over time. So basically, that's why we need kind of the combination of the force of both real-time analysis and as well as offline or like the batch analytics.
Gotcha. Yeah, I mean, and even to your point of what you had brought up the fraud use case, like bringing in a whole bunch of those over time, you can then kind of start to build a pattern of what does fraud look like, and can we kind of run classification or figure out how to detect this fraud beforehand using previous examples. And so, yeah, I mean, the examples can be endless there of data that is aggregated and especially like pulled together in hindsight can quickly become of much more value, especially when applied to that real-time ingestion, like data coming in real time. So very cool. Very cool discussion there. So unless there's anything you wanted to kind of touch on more on the maybe more theoretical side, do you want to jump into the Pinot architecture a little bit to kind of tell us a little bit, just to kind of give us an idea of how you managed to do both real time and then sub-second latency?
Yeah. So basically from Pinot side, so we can first start with like the data ingestion perspective. So from the real-time ingestion pipeline, Pinot can subscribe data from like Kafka or like Kinesis and get data into Pinot real-time server. So for Pinot real-time server is like have embedded Kafka consumer and consume data and do indexing. And then Pinot will try to store the data into a deep store, which can be either your like local network file system or like let's say Amazon S3 or like HDFS or Google GCS, up to the user. And apart from that, Pinot has something called the offline server, which can load the data are like built from like Spark or Hadoop. So for those segments are kind of Pinot's lowest data batch. And from the query perspective, Pinot has a broker which will be very smart to figuring out what are the real-time server and the offline server to ask my questions. It will basically try to automatically handle the time boundary change so that it will query the offline server as much as possible, and then query the real-time server for the gaps. So basically, this is like a Lambda architecture.
Yeah, I was just going to say that.
Yeah, and all the query are going to broker and being distributed to like all the servers. Broker will also handle things like load balancing, and also broker internally will have some concept of like partitioning. If user has config the data partition, and the Pinot will only look up that partition based on your query. You're only filtering on that partition, then we won't do like scan the entire table. You will only look at that particular shard. Apart from that, we are also like looking at expanding the real-time server to offline server part, which means that people just pointing to, let's say, Kafka and forget about that. Internally, we'll try to move the persisted data from real-time server to offline server, so that you can just probably set a very, very long retention and just keep adding machine or your VM into offline server pool, and then your table will just be sitting there. So in practice, we basically have like cluster with like couple hundred to like 1,000 machines. So that's kind of our biggest clusters, and it can serve like probably I wouldn't say like 100 terabytes, but that's really the biggest table we observe right now.
Wow. So, and I real quick question back to your kind of moving things segments from real time to offline. What's responsible for that? I was just kind of curious to ask that bit.
Oh, okay. Yeah, if you think of this one, if you think of like the real time server, right, it has like embedded Kafka consumer. So, or like Kinesis consumer. So because in your Kafka and in your Kinesis, your upstream is already sharded, which means that let's say you have 4 Kafka partitions. There's no means you have like 1,000 real-time server, because only 4 Kafka consumers are working. Right, so you basically have 4 servers really doing the indexing, and they will like index the data and persist it. And once they finish, we will try to move those things from the real-time server to offline server. So real-time server will be majorly working on like the data indexing and consuming this kind of work. And the offline server will be able to handle much larger workload, and also we will basically, because your local disk is also limited, so we want to help user to scale based on the offline servers.
Are those segments kind of like based on time, like at some particular time increment, you'll move from real time, like let's say you write for every hour or something, or write for every like day, and once so you have those 4 partitions coming from Kafka, they're streaming into a segment, and then as soon as the time hits, they start streaming into new segments, and then you would then have some task that move those into offline. Is that
correct?
Okay. Cool.
Yeah, basically it's like we have something called a tiers. You can basically configuring by saying, I have my, because my lookup may be like mostly on the recent data, right? So I may configure by saying that for the recent 7 days, I want to put all those segments into a SSD disk tier. That will improve my performance a lot, right?
Yep.
And after 7 days, I will probably move everything to like the cheaper hard disk.
Yep.
So that's kind of things you can configure.
Cool.
When you which tier you want to move your data to.
Very good. Cool. So without, is there anything else you wanted to cover on architecture? We might move on to the PR of the week, if unless you wanted to mention a few more things.
Yeah, I think let's move to the PR of the week. So,
sure.
Yeah.
Okay, so Elon, you're up. We tend to do this where we drag on really cool stuff, and I think this is super cool. So so you are, as you kind of mentioned, you've been involved with Trino even all the way back in the Presto days, back at Facebook with Martine, Dane, and David, and so you're pretty well ingrained in our and basically what we do here. And so what got you kind of working with Pinot and kind of start working on this connector?
Yeah, I just want to say first, thanks to the Trino and the Pinot communities for welcoming like changes and being so helpful.
Sure.
And helping users all the time. But yeah, so after I left Facebook, I joined a stealth mode secret startup that I'm part of now, and
cool.
we really needed real-time data.
Cool.
So and we also had an analytics team that needed to do complex queries over that same data
Sure.
as well. And we researched a few different products like Druid, ClickHouse, Pinot, and looked at blogs, just tested out how the usability was, and chose Pinot. Just, it was easy to set up. The performance is great. It's been stable, and Trino, you know, everyone loves Trino, so that was a no-brainer. But at the time, there was no connector to Trino, so we took there was a connector in the old Presto repo, and completely rewrote it, refactored it, and allowed us to allow data engineers and real-time dashboards both to connect to Pinot through Trino.
Oh, cool.
Yeah, and the main stuff to get started, you only actually need to set the Pinot controller URL to a comma-separated list, or if you use Kubernetes, that's a common use case. Then you just set it to the service name and the exposed port, like Pinot 9000 is the default port, for example.
Okay.
We try to go with the Trino concept of have minimal configuration and then just have sensible defaults. But the other most commonly adjusted config parameter is the number of rows per segment that you can return. And this is because when we hooked it up, we innocently were doing select star and crashing the Pinot servers because they were exporting all the data. So we can go into a little more detail later about that, but it's Pinot max rows per split for segment queries, which brings us to the next item. There's two APIs, actually three now, to connect to Pinot. The first is through the broker, where, as Yang said before, you know, you can do all the smart aggregations, filtering, pruning of the segments, which is how the data is stored in Pinot. And then the other API is a server API, which under the hood, the brokers use. We use it directly for, like, if you want a large export, or if you want a query with no filter, for example.
And that's hitting the offline server, I guess?
They hit the server, all servers, both real-time and offline.
Okay.
Unless you specifically say that you want to select from the offline table or the real-time table, that's a suffix.
Gotcha.
Offline.
But the connector handles that logically, like you don't have to worry about what it's hitting, broker or server, it does that.
Right. So the way, by default, it'll just hit the server. But if you want, you can do this, what we call pass-through query, where you select from the table name. So it'd be something like select star from, and then in double quotes, a Pinot query. And this was before all the aggregation pushdown and other cool features were implemented. So we were able to push the entire query down into Pinot. And
yeah, that's very interesting, because I was wondering when you were all talking about how Pinot has all that smarts. So the native language for Pinot is also SQL. So it has its own SQL.
It also uses like a kind of more standard SQL language, but there's one called PQL or BQL that you can use. But for the broker queries, we use actually just the standard SQL. We found it to be more stable, and they're deprecating the other ones. And also we found that it also had some correctness improvements.
And the pass-through that you mentioned, that basically, like I was wondering, because otherwise if you just send if you like naively write a query in Trino, it would do a lot of the aggregation and try to do that, and then all the benefits of Pinot would basically disappear to some degree, right? So you're saying this pass-through enables you to, as a person writing the query, understand this is already pre-aggregated in Pinot, so I'm not gonna even bother Trino with it, and I just pass it through. So you need to have a bit of understanding of what's already like available in Pinot as a pre-aggregation stuff, basically, right?
Yeah, that's right. And usually we use them for a dashboard query where we work with people, because it's a little bit tricky, the syntax, but the benefits are, then you can get those millisecond queries, or like 20 millisecond queries. And there's also an open PR that we actually use in our production to enable aggregation pushdown.
I have a
And
little like diagram here, so it's kind of showing and this actually shows the Trino workers talking directly to the servers versus talking to the broker. So would you want to talk a little bit about how that aggregation pushdown feature works while we're on it?
Sure. So when you enable it, when the metadata goes to the apply aggregation, Pinot under the hood, the Pinot connector builds up a broker query, and it will just add the aggregation functions to the broker query, like the group by, in addition to the already implemented filter and limit pushdown. And so this way, when you run the query, it actually turns a regular query, like select users count or some revenue or from your Pinot table, it will actually turn that into a broker query as if you were doing the pass-through query, with the advantage that you don't have like some of the case sensitivity issues that you have by doing a query as an identifier, which, by the way, is also very similar to how the Elasticsearch connector works. Yeah. And Martine actually gave us the idea to do that. That was really awesome. Yeah, so that's about the aggregation pushdown. We do also have some work on we in production use insert because we were having these Flink jobs and just like reams of YAML to configure the Flink operator, and so we figured it'd be much easier for our engineers to just do inserts into offline tables from Pinot, and it's been working for us. We also have an open PR for that. That's a pretty interesting one. It'll shard the data to this, like a worker for a specific segment that's based on the time column, and then generate the segment and push the data, similar to how you would run on one of the Pinot minions, but you run it on the Presto worker.
Wow, cool.
And yeah, we also implemented create table just so we could track and log Presto Pinot table data through like our logging framework, so you can directly create a table from Presto and also do show create table and see the different properties that the Pinot table has. And then in future work, we actually want to eliminate the broker as that pass-through query and allow something similar to how Pinot has Groovy functions in there. You can inject a Groovy function into your Pinot SQL. We'll do something where it's on the column level and it'll just natively use all the aggregation and filter pushdown that's already in the connector.
Cool. So when you're using some sort of BI tool or whatever with Trino and you connect it down to Pinot, you just write those queries however you would want to write them, and it'll work just fine, basically, because the result sets are just normal data result sets. That's
cool. Yeah, and for those pass-through queries, typically there'll be like a fixed query that's used to populate a real-time dashboard. So we'll create a view out of the query, so end users don't, they have a much easier time working with the data when they don't see like select and then double quotes and then a query. And
yeah, so so it's basically a materialized view or like some sort of like plain table that looks like, and they can just go. Oh,
yeah,
that's nice.
Very cool.
So under the hood for all, like I sort of like didn't get all the details earlier to some degree, wasn't sure. Under the hood in Pinot, what's enabling all this like high latency beyond, like what storage engines do you have underneath it? Is it just all the like Azure storage and like the object storage systems, or are you also hooking in some relational databases as well for the storage, or is there some in-memory storage happening as well?
I guess Jiang, if you want to answer that.
Sure. Yeah, so Pinot itself has basically its own way of like storing data and build the index. So it's all on disk. That's why when I talk about previously, I would say SSD will perform much better. And Pinot internally will basically have its own kind of own format of storing the data and build a different kind of index on top of the data.
Oh,
So
okay.
it will
So
help the
it's
user
own
to,
format.
yeah, it's its own format, right?
Okay.
Yeah.
And that's, I guess it's like open source, but internal to Pinot.
It's everything is open source, right?
Yeah, I know.
You can read the source code. Yeah, but I guess very few people will do that. But it's all welcome because there are like many different algorithms, and it's actually very good learning, especially for people who are interested in data structure. This is a very interesting problem to solve.
Yeah, definitely. So one last thing, I think Elon, if we can cover, so let's dive into, like, there's been a lot of interest on both the Pinot and the Trino side to kind of understanding what's coming up for eliminating this broker query parsing, and so if you could just dive into that and kind of like go into like I guess a common question you're getting is like, why is my pass-through query like failing? And so I think is that actually the one that we used as our question of the week? Yeah. So why does we'll cover the question of the week, and then we'll actually end up finishing out on the demo here. So the question is like, why does my pass-through query not work in the Pinot connector? And what are we doing to kind of fix that? And I think I mixed two things. I think the other one I want to see is the server limit solve. So in whatever order, you could talk about maybe the pass-through queries first.
Yeah, so the pass-through query, that's the most common question that we see in Slack and our users. It's because the most common reason is because the identifier is lowercase. So although the connector does its best to match columns that it parses from the pass-through query to actual Pinot columns, they may be mixed case. The most common one is you have a lowercase, a constant that's uppercase gets lowercase. And the two ways to solve that are, one is to move the filter outside of the query if that column is exposed in the select list. Mm-hmm. And that way you can use Trino's filter pushdown, which will preserve the case of the constants. Another workaround is to just wrap it in upper if it's a completely uppercase constant. I know that's not always possible. Otherwise, you would have to filter it outside of the double quotes to get that working. And we are working on evolving past that by being able to just mention columns in double quotes.
And maybe if we could get, I think one thing I just thought of for the answer and something we can add in the show notes after this would be to like have a quick example of something that would fail, and then like the kind of two ways that we could actually wrap that. So like two SQL examples. That might be something.
Sure.
Yeah.
Sure. I have many of them. So, yeah. Awesome. And the other one for the server, like if you just do a select star from a Pinot table, if you only set up the Pinot controller URL, you'll likely get, exceeded limit for segment query 50K, which we found to be a reasonable limit. So there's two choices. You can either raise the configuration, but then you'll have the risk of putting too much load on your Pinot servers, or you can use a broker query. And we actually worked with the Pinot community to implement a streaming connector that uses gRPC streaming. So we want to put that in the connector also. So for regular server queries, it'll just use this other endpoint that directly streams the results to Presto.
That's very cool. Yeah, because I think you were saying like, so when you do going the other way through going through a directly to the server, you're typically having to the reason why it's crashing is because it's doing like batches, right? And so it ends up taking up a lot of memory on the Pinot side. Is that correct?
Yeah, memory, disk, network.
Yeah, so it's basically tapping out all these resources when you're like basically scanning through these terabytes. And so if you're pulling that out, that's an easy way to crash your Pinot server. And so the streaming alternative would still be pulling that data, but it's basically not having to take up a lot of those resources except for transferring. Is that
right? Yeah, and buffering the data. It doesn't buffer as much data before it sends it.
Cool. Cool. So that's something to look forward to. I mean, is there obviously like in open source, right? There's no perfect timeline, but do you have like any idea of like when users might be expecting to see something like that come about, or?
Definitely before the next election. No, I'm kidding. Definitely like in the next few months,
Okay.
I would say.
Okay, cool. Yeah, I mean, obviously, like this is something I get constantly asked too. Is like I'm helping out somebody and I'm thinking, oh yeah, let's get an issue on this, and they're like, how soon do you think this issue will get done? I'm like, man, it's open source. Like, never know. But
you contribute the fix, then this goes faster, right?
If you get the fix, yeah, we'll get that in.
But yeah, it should be in the next few months. It's we actually did some experiments with it already. We just need to open source.
Very cool. Very cool.
I have a related, yet to be determined date question to Chang. I just noticed that Apache Pinot is incubating still.
Right. It is incubating. We're working on the graduation part. Yeah.
So no ETA yet.
I think it will be very soon.
Awesome.
And apart from that, incubating is just a phase of like Apache. So
I know it's just ticking all the boxes that Apache needs, but it's a long process. I know we talked last time with the Superset folk, and they were very happy when they got through it and like graduated and stuff. I'm sure you'll be celebrating too once it's done.
That's definitely worth a bottle of Pinot, probably two.
Okay, so yeah, Elon, did you have anything else you wanted to share with us about the connector at all, or Zhang, do you want to have any other thing you wanted to cover before I move on to the demo? It's going to be a very short demo. Don't worry.
Yeah, I think I'm good.
Okay.
Yeah.
All right, great. So let's get on to a little bit of a demo. Let me just clear out all the junkety junk I've typed before. And then I need to move. So basically I've pulled together, it's a ridiculously simple like demo that I've modified from what's on the Pinot website. For listeners who want to dive into this afterwards, I have a little repository called Trino Getting Started that I'm putting together. It's very much like under construction, like I'm force pushing to it. So like just copy the code down for now and don't actually expect to like fork off and do things with it yet. But if you want to play around with Pinot a little bit and just like a little Docker environment, I have a starting to work Docker Compose image that you can pull there. And so look in the show notes and go ahead and clone this down, or even just download it temporarily. And then just change directory into Pinot, Trino Pinot, and that's what I'm actually about ready to get ready to do. So we want Trino Getting Started, and we'll go into Pinot and then Trino Pinot. Okay, so once you're into the Trino Pinot location, we want to start up Docker. So I've actually already done that beforehand, just in case it took a minute. And then once you start up Docker, by the way, there is still a trick that an issue with Zookeeper that I'm working out there. I was not able to get it fixed before the show, but if Zookeeper doesn't start up soon enough, then you'll have like 2 of the other containers fail. You just need to run Docker Compose up 1 second time, and then it'll be up for good. So what we're basically going to do is we're going to take this path here. If you look at the architecture diagram, where we're just basically ingesting raw data and putting it into a segment and automatically storing it as an offline set of data that Pinot can search over. So we'll store our raw data on a local file system, which is just going to be in my temp directory under temp Pinot quick start and then raw data. And then we're going to basically push the CSV file into under raw data under transcript.csv. So we go ahead and do that. And then in order for Pinot to understand the CSV schema and stuff, we're going to have to add explicitly a schema for Pinot to basically make sense of those different columns, and as well as just, I'm sure it uses again some smarts on understanding like the different fields and the different columns. So we'll go ahead and add that schema. Again, all this is just copying and pasting like this echo statement where it basically just pushes this out into a little file that we're going to end up using in a Trino command here shortly. And the last thing that we need is a table definition. So this is just going to basically say, use this schema, use this particular index, and here's the basic configuration, and then the table name, things like that. And what's the timestamp column as well. So we then create the table definition, and once you've got those three files, you run what's called like a add table command using this ingestion framework, and that's done through a Docker exec call, and that's going to run over the Trino network that I'm against the Trino network here, so that I can actually run this against. I believe I'm running this against the server itself, the offline server, I imagine. So let me go ahead and do that. And actually, right now, I can go into this nice little web UI that Pinot serves up at port 9000. And now I can actually see all the, I have a couple controllers, brokers, servers, and then I can actually look at, I've created one table. And so it's showing me the offline table that I just created, but there's currently no segments or no data sitting in this. So if I go to the query console right now, I'm going to basically just get, I click on transcript table, I'm going to get no data back, right? Expected. And so now I need to actually write that data into a particular segment. So let me go back, and we need to take this job spec. This one was interesting, working correctly in an echo statement. So let's see if this fails. All right. Well, at least it wrote, so that was one good thing. And then now that we have this job spec, what basically this is doing is it's going out to particular classes that will be able to understand basically pull in the CSV file that we wrote there, that transcript file, and output it to a same location, but basically output a segment on my local file system. And that's what Pinot is actually going to be using to as Jang said before, it's using this local file system, using this all these fancy indexes that get spit out under this particular directory. So that's all that's happening here. And now that we have that ingestion job defined, we'll go ahead and actually run that ingestion job using yet again another Docker run command. And hopefully it works.
To say the Pinot web UI looks pretty powerful.
Oh, it's pretty neat
and everything. It's very nice.
Yeah, they have I didn't even get in, but they have a Swagger REST API set up. So if you want to play around with like the REST API and stuff, I'm not going to jump into it because it's a bit tangential and we're running out of time. But you can, if you've used Swagger before, you can basically like just input the different values, and then it automatically creates your REST call and all this stuff. So it's really nice. And you also have a Zookeeper browser. You can go ahead and like look at all the different Zookeeper nodes and stuff that have been created. So see if everything's being set up correctly. So anyways, so now that we've run this, what's happened now is we should see one segment that has been created under that table. Wait, no. Well, we're going to see data here in a second. Where am I trying to go? It's under tables. There we go. Now there's a segment here. So we see that there's a segment. There should be some data sitting in there. And by the way, if it's not clear, I don't know if we've mentioned this, but segment is literally just like, in other words, like a partition or just basically where the data gets written to. So now when we pull this data out, boom, we see all that data coming up in Pinot. Now the next question is, we also have a little local Pinot running from Trino Coordinator here. So same kind of thing. Like you could pull up our little web UI. So oops. The Trino web UI and log in, and basically look at any queries being ran, but now we can actually pull up, I'm going to pull up dbeaver. that's going to connect to Trino here. Let me make sure to refresh that. And we have a Pinot catalog here, and didn't specify a schema, so we have that now that showing the transcript values, and we pull up data. Server refused connection. It's probably some strange Docker mapping bug. I literally had this working earlier. What's going on here? Okay, well, I'm not, oh, there it is.
Timing.
Yeah, exactly. So now we also get the same thing showing up in Trino. But yeah, and that's, I mean, nothing mind blowing, but it's just to kind of highlight the work that Elon's been doing, getting this set up. So I wanted to go back to the actual, here we go. So this is, the PR of the week, by the way, is the initial Add Pinot connector. So that's basically all we wanted to showcase here, and just basically have a simple run through. If you're wanting to try Pinot out for yourself, and as along with Trino, there's a quick little Docker Compose setup that you can do there, and pull that up and start playing around with all the different configurations and stuff. So again. Thanks a lot to Zhang and Elon. Thanks for joining us on this, and I hope everybody out there who is either coming in here from the Pinot side learns a little bit about why you'd want to use Trino, and vice versa if you're one of our Trino tree knights. I still got to figure out a good word for our community, but for our Trino folks, I hope you found why Pinot is just such a useful part of an architecture, and just adds that more value to your kind of historical data, as well as just bringing your BI and anomaly detection stuff to life. So anything else you want to add, Zhang or Elon, before we hop off? How do people get in contact with you if they want to learn more about Pinot?
Yeah, definitely. At Pinot, we have a Slack community. Cool. Basically, you can join Apache Pinot Slack community. I will put the link there. And apart from that, on Meetup, we will have an intro to Apache Pinot session next week. I think it's next Thursday, March 25th. So that will be a good introduction to Pinot if you want to start from there. And we also have many, since Pinot is the Apache project, so there are enough documentations and website you can just probably Google for. But in short, it's pinot.apache.org. Yeah. And please definitely join Apache Pinot Slack. So that at there you can ask any questions, and also if you have any problem, you can just ping us on the channel. Yeah.
Real quick, Zhang, is that meetup? Is that on meetup.com? Is that one of those?
It's meetup.com. Okay. We'll share the link.
Sure, and I'll go ahead and put that in the show notes whenever we're done there. Great.
If you ever have questions, just CC. I'm on both Trino and Pinot Slack, so if you have any questions, just put my name and I'll respond before the next election.
Yeah, and definitely find him on Twitter. He's very active on Twitter.
Awesome.
And that actually reminds me real fast. I was supposed to talk about this. So we are actually getting back into our Trino meetup groups as well. We have a couple spread across the land, but since we basically bought these right before the COVID times, and now we haven't really done much with them except for kind of advertise a couple virtual meetups. With that, we are trying to get virtual meetups as a continuing thing that will happen even after we're able to do face-to-face again. And this is going to eventually be just divided by time zones, so that if you're not in one of these kind of local areas that we're trying to build out, that we can essentially you'll still be able to engage with folks and that are at least in the same time zone as you. So more stay tuned for that. We're going to be having more of that on the Trino site itself, but for now I've added those to the show notes for now as well. So thanks for reminding me about that. Manfred, do you want to mention anything before we hop off?
Yeah, one last thing. I wanted to mention two little things. First of all, Trino support arrived in Redash now. So the PR for that was merged. So any Redash users, go try it out. You can now easily connect to Trino with Redash. That's really awesome. And the other cool thing that's on the Trino blog is there's a blog post from Kasia Findeisen that goes really in depth about some of the new features that we added to window functions and stuff like that. If you want to geek out on some SQL dialect usage, check that out.
For sure. Awesome stuff. All right. Well, last thing I got to mention, music for the show is from the Mega Man 6 gameplay album by Krzysztof Slawikowski. And that is the Trino Community Broadcast for today. I'll see you all in about 2 weeks.